Welcome to homework.
Hello everyone, today we're doing chapter 29, problem 44, and this problem asks us to devise a synthesis for each of the amino acids from acetaldehyde. So we start from acetaldehyde. Oh, acetal means two carbons, aldehyde means has a hydrogen off the carbonyl carbon, and the first amino acid of interest is glycine. So I'm trying to make glycine which looks something like this. So how do we make this acetaldehyde into glycine? Well, something that we can do is we need to make an electrophile on this molecule such that we can add this nucleophilic amine on it. So well, let's take a step back and first count the carbons. So in the starting material, we have 2 carbons, and in the product, we also have 2 carbons. So we can imagine that this carbon number 1 with the R group of hydrogen, we need to add a leading group to that. So we can just add, for example, a bromine to that, such that afterwards I can do an SN2 attack with this amine to get this something closer to this amino acid glycine. And then afterwards, you can just oxidize this aldehyde up to carboxylic acid very easily. So let's first figure out how we can add this bromine group here. So starting from acetaldehyde, if I add diatomic bromine and acetic acid, we will get this structure here. And now if I oxidize this carboxylic acid first, because I don't want to have any reactivity with the nitrogen accidentally hitting this aldehyde. So let's first oxidize this up to the carboxylic acid. So we can use chromium trioxide and a strong acid. So we just say aqueous solution, and this will oxidize our aldehyde up to the carboxylic acid, at which point I can just add excess ammonia. I guess react this in a solution of ammonia, 32% ammonia, to get that SN2 attack that we're talking about. To get glycine. And now for B, an alanine, so let's draw alanine. So this is alanine. So once again, let's see, if we're starting from, this is our end goal, and we're starting from acetaldehyde. So let's see, here I need to add one more carbon, because here I'm starting with 1, 2 carbons, but here I have 1, 2, 3 carbons. So I need to add a carbon. I need to add this amine. So just like from the textbook, if you recall the reagent, if I add NH4Cl with sodium cyanide, NH4Cl with sodium cyanide, then I will get something that looks like this. So here now I added one more carbon, so now I've satisfied the number of carbons, but now I need to oxidize the cyano group into this carboxylic acid in order to get alanine. So that's what step 2 comes in. This is just acidic conditions, H3O plus, to hydrolyze the cyano group into this carboxylic acid. And this gives us alanine, just like the question STEM asked us for.